Hey guys. Hey there, Mrs. Banky. I'm back. It's a bit of a mystical character today. If you haven't been able to tell, I'm a ninja. So, this is going to be a brief PowerPoint because I'm having a hard time talking through this uniform. I guess I could probably do that. Nah, it takes away the ninja. Anyway, so today I'm going to talk about the elements and how they're organized on the periodic table primarily. So you already did the periodic table activity. One thing that I want to point out is that there are some symbols that do come from older names. They don't seem to be related to current names. One example is sodium. And sodium's used, it used to be called natrium. In some countries it still is called natrium. Now on the periodic table, the vertical columns are called groups or families. And they all have very, very, very similar properties. So for example, group 17 elements here are the halogens. They all behave very similarly to one another, as do group 1 elements behave similarly to one another. So each group contains elements with similar properties. Also, when you look at the periodic table, you'll see that it's numbered one of two ways. You see the groups labeled across the top 1 through 18, and then you see another numbering scheme. Sometimes this will be in Roman numerals, like a Roman numeral 1 or Roman numeral 2, but groups 1 and 2 are part of a group with this set of elements right here. These are called the representative elements, or the main group elements, and they all have a letter A in their group distinction. So 1A, 2A, skipping all the way over to here, 3A through 8A. And then this group of elements in here is the transition metals, and you can see that they are B elements, and they have kind of a goofy numbering scheme. So two different ways to number the periodic table. Across the bottom of the periodic table is a group of elements called the lanthanides and the actinides, and these are the rare earth elements. I guess before that I'll talk about periods. Periods are horizontal rows, and the properties will change very regularly or periodically. And we will talk about that in a future unit, what sort of changes take place as you go across the periodic table. Some very regularly occurring intervals or periodic intervals, which is where the name originated from. So the lanthanides and actinides are placed below the table to keep it from being too wide. So you see here, this is number 57, and it comes after number 56. And this little block here represents all of these elements right here. And this little block represents all of these elements right here. So if we included it in there, you can see how wide the periodic table will be. And that's just too wide. It's not convenient. So it doesn't really fit in with our group numbering system either. So they're rare earth elements, and they kind of have characteristics of their own, and they don't fit a lot of the schemes that we see. So a periodic table of elements includes two bits of quite a bit of information: the element symbol here, the atomic number, and the average atomic mass. We'll learn in detail how to deal with these numbers in future calculations and wherever we need to use them. This is a periodic table from another country. I think it may be from either Paraguay or Peru, or maybe some other country that starts with a P. I don't remember. The point is, The element names are different. So boron is boros. Carbon they call anglise. I am sure I'm not pronouncing that right. But one thing that stays the same is all of the element symbols and atomic masses and atomic numbers stay the same. We use this globally as a common language with the same symbols, the same numbers, and everything. The only thing that really is different from country to country is the name. So when you did your periodic table activity, you broke your periodic table down into metals. Actually, this slide right here shows that the metals, the metalloids, and the nonmetals. Now, this particular periodic table does include polonium instead of astatine as a metalloid, so there's some disagreement there. Don't worry, I know that you colored astatine and not polonium on your periodic table. That's just fine. So your metals are a group of elements that are shiny and good conductors of heat and electricity. Most of them are solid at room temperature, with the one exception is mercury. They're malleable and ductile, and most have a silvery gray color, with the exception of gold and copper. Some are very, very reactive, like potassium and sodium and lithium, and some are highly unreactive, such as gold. That's one thing that makes gold such a metal used in jewelry, because it's very durable and it doesn't corrode very easily. Here are some samples of some metals. I'm not really sure what's going on up there. I guess it's a GIF or a GIF or whatever it is they call them. I don't know. Your nonmetals, most of them are gases at room temperature. Only one is a liquid. That is the foul-smelling bromine. These are elements that are poor conductors of heat and electricity. A little bit later in the year, we're going to talk specifically what it is about these categories of elements that gives them these properties. And just like in biology, where structure determines function, it's the same thing in chemistry. It's really exciting. Here is some sulfur and some iodine chips, and this looks like a piece of carbon graphite. Metalloids have similar characteristics to each of the metals and nonmetals. For example, silicon is very brittle like a nonmetal, but it conducts electricity like a metal. So this is a sample of silicon, and I am not positive what this is. I am sorry, I forgot. I really don't remember. If I told you I knew what it was, it would just be a lie. Your noble gases are the very last column on the periodic table, column 18, also known as 8A, are very unreactive. They are so unreactive that they weren't even known of prior to 1962 because they weren't part of compounds. They were discovered late. Once one was discovered, several were discovered after that. So between this and the periodic table activity, I hope that it gave you an introduction to basic categories of elements and will help you prepare for a test as it comes up. Thank you. That's it. I am going to go practice being a ninja somewhere, and I probably need a lot of practice because I've never done it before. In fact, this costume has been in my desk drawer since Peter was about maybe 4 or 5, and he went to the community Halloween party in the old gym here at O'Connell Falls High School. So it's just been hanging around. The bottom part of the costume definitely does not fit. However, this part fits me pretty good because I have a tiny pea-sized head. So that works well for me. Well, I hope you have a good night. It's a good night for me, so I'm going to say good night to you.